In this course, we are going to be creating a 2D action RPG game. So, this is going to be a game with these base mechanics with a lot of room for you to expand upon in adding your own or using the knowledge you learned here to create many types of different games. So, what are the things we're actually going to be learning in this course? Well, when it comes to Defold, we are going to be learning a number of new and different systems, such as a top-down player movement controller, camera following and clamping the camera's position to a restricted boundary. We'll be looking at a simple enemy AI, health bars that can be above the player and the enemy's heads and follow around as they move. We'll also be creating a level management system to load our menus and our game scene. And we'll also then look at object spawning to actually spawn in these enemies and spawn in the projectiles that the player shoots. Now, this course requires a basic understanding of Defold and Lua. We are not going over the basics here. We won't be going over the basics of Lua or how the engine works. That is going to be assumed knowledge, okay? You should be able to work in the engine, create objects, create scripts, know the basics of how variables and functions and conditions work. So again, this course does require a bit of prior knowledge. Zenva is a learning academy with over 1 million students. We feature a wide range of courses, for those who are brand new or for those who just want to learn something new. The courses are versatile, allowing you to learn in really many different ways. You can follow along with the video lessons, read the included lesson summaries, or follow along with the included course files. Okay, so before we jump into Defold and actually get to making our game, let's first of all go over the different elements and systems that we are going to be creating. So first of all, what is the game? Well, basically, the game is an action RPG, or the foundations of one, with the objective being to survive for as long as you can, okay? And we do that by defeating enemies and avoid taking damage as the player. Now, there are three main elements that we are going to be creating in our game. That is the player, the projectile, and the enemies. Now, for the player, you can move them around with the W, A, S, and D keys, and you can aim and shoot projectiles using the mouse. Now, along with this, we're also going to be adding in some flashy features for the player, such as a health bar that follows above their head to represent their health, a damage flash, so when they get hit, they will flash red for a fraction of a second, sprite flipping, so they will face the direction that the player's mouse is, either left or right, and also shooting and damage sound effects. The enemy is going to be spawned in over time, so basically we're going to pick a random position on the map and spawn an enemy there, then 1 second later we'll spawn another one, and that time can of course be adjusted. Each enemy is then going to chase after the player, and when in range they will stop moving and then begin attacking them. The enemy, like the player, is going to have a health bar, damage flash, sprite flipping, and damage sound effects. Now, when it comes to the projectiles, these are the objects that are going to be spawned in when the player shoots, and they are going to be spawned in with the left mouse button, and they're going to move in the direction of the mouse as well. And when they hit an enemy, they are going to deal damage to the enemy as well as destroying themselves. Now, along with this, we're going to create a menu level as well, so the player can choose to either play or quit, and controlling all of this is going to be our game controller. Now, the game controller is going to be a sort of behind-the-scenes thing. It's not really going to have a visual or physical game presence, but rather it is sort of the core of our game. When we launch into our game, we are not going to launch into our menu collection or our game collection. We are going to launch into our game controller collection. And here is where it will then go, okay, we have launched the game, let's load up the menu. Then when we want to load up the game controller is going to do all that manual work in order to unload the menu and then load in the game, and vice versa if you want to go back to the menu, okay? So the game controller is going to be a very important part of the actual game flow. So now let's get started with the first lesson of setting up our Defold project. Alright, so let's get started on our project. So here I am inside of the Defold launcher, where we can create a new project on the left hand side, and we are going to choose the empty project template. Okay, we're going to start from scratch. So we can give our project a title and then click create project. Alright, now inside of our Defold project, before we actually begin creating our game, we are going to work over here in the assets panel where we're going to set up our folders and import some assets. So first of all, I am going to create two main folders. So I'm going to right click on my root folder, go new folder, and I'm going to call this one game. Now, inside of the game folder is where we are going to be storing all of the game related assets, okay? Such as our collections, our scripts, our GUIs, everything that we are going to be creating in Defold and using inside of our game. Now, inside of this game folder, we are going to create a number of different folders. So we're going to start with a new folder, and we're going to call this one entities. Now, entities are basically going to store things such as our enemies and our projectiles, things we might want to spawn in during the game. The next folder is going to be levels. This is where we're going to be storing our different levels, such as our game and our menu. We are then going to have our player folder, which is going to have all the player related objects and scripts. And there we go. Now let's create another folder inside of our root, and this one is going to be called assets. And inside of here is where we are going to add our audio clips and our sprites. Now, if you go to the course files tab and download the assets zip, you should see something like this when you extract it, an audio and a sprites folder. Inside of audio, we have a collection of different sound effects, and inside of sprites, we have a very large sprite sheet that we are going to be using. So what I'm going to do is I'm going to drag in the audio folder into assets here to import it, and same with sprites. So now we have our audio clips imported as well as our sprite sheet. Now with our sprite sheet, we are going to need to set this up because right now we can't use this image for anything, okay? We need to basically create what's known as a tile source, and a tile source essentially gets this sprite sheet, chops it up into individual sprites. So for this, what I'm going to do is right click on sprites folder, go new, and then go down to tile source. Okay, I'm going to call this one our sprite sheet underscore tile source and create that. Now, the first thing we need to do is over here in the properties window, we are going to go and set the image. So click on these three little dots and select our sprite sheet image and click OK. All right, so that is then going to load in the image, but what we then need to do is change the tile width and height, because if we zoom in here, you'll see that the tiles are cut up not in the way we want, okay? They're basically half the size of our actual tiles. So over here in tile width, I'm going to set this to be 32, and also go ahead and change this based on whatever sprite sheet you are using. If you're using a different resolution sheet, then set these numbers appropriately. So the tile width and tile height, I'm going to set to be 32. Now, as you can see, all our tiles are nicely cut up to their correct size. Okay, we're going to continue with setting up our tile source later on when we want to grab sprites for our player and for our projectiles and our enemies, etc. But for now, we are going to just save this and leave it as is. Now, the next step we're going to do is go ahead and create our main collection, which is going to be our game. So inside of our game folder and then inside of levels, I'm going to right click, go new, then go down to where we have collection. Okay, and I'm going to call this collection game. This is essentially going to be where we're going to have our enemy, our level, and everything else we want to spawn in, such as our enemies, to basically run our game. Okay, think of this as the game level. So, before we continue on with creating everything, we need to make this game.collection the collection that runs when the game starts. So to do this, we are going to go down to our game project file here in the assets folder. We're going to click on that, and it's going to open up our game.project. We're then going to go over to Bootstrap on the left-hand side and change the main collection over to that game.collection, just like that. Now, if we press F5 to run our game, we should see that it launches into our game collection here. But of course, we don't have anything at the moment, so it's kind of blank. Now, in the next lesson, we are going to begin setting up our player, okay? Starting with our player's inputs, then setting up their collection, and then going ahead and scripting them so we can move around, shoot, and basically have a fun little character to control. So thanks for watching, and I'll see you all then. In this lesson, we are going to begin setting up our player. Now, before we jump into creating our player's object and script, we first of all need to create the keyboard and mouse inputs that will be used to actually control our player. So to do this, we are going to go over to the input folder here, and by default, we'll have a game input binding file. So I'm going to double click on that, and this screen is going to open up. Now here we can define our key triggers, mouse triggers, gamepad triggers, etc. So when a specific mouse button or keyboard key is pressed, that will trigger an action that we can then read in script. So for key triggers, meaning our keyboard, we essentially want to have our movement, so left, right, up, and down, and we're going to do that with the W, A, S, and D keys. So here I'm going to click on a plus, and we can then go over to where it says action and double click. And I'm going to rename this to move_up. Then where it says space, this is the input. I'm going to double click on that. And we can then go ahead and search through this list for the keyboard key. Now for moving up, we're going to use W. So let's go down and select W. And then I'm going to go through and do the exact same thing for move down, which is going to have the S key. Then move left, which is going to have the A key. And then finally move right, which is going to have the D key. Okay, and there we go. Now finally we need one more input, and that is going to be down here for our mouse triggers, and this is going to essentially be the shoot button. So I'm going to add a new action to the mouse triggers. I'm going to call this one shoot, and this input is going to be button left, which is the left mouse button. And there we go. So that is our inputs set up for our player. We can then close out of this window. And now let's actually get set up with our player. So for our player's object, we aren't going to be defining the player as a game object here in our assets, but rather a collection. The reason why is because this player collection is going to contain both the player object and the camera object as well. So I'm going to right click, or I'm going to go to the game folder, then down to the player folder. I'm going to right click on that, go new file, and I'm going to create a collection. This collection I'm going to call player, and then we can create that like so. Now inside of our player collection, we are going to go to the outline and create a new game object, which is going to represent our player's object. So I'm going to right click on collection, add game object, go down to properties and change the ID from go to player, and there we go. Now our player is going to be constructed of a number of different components, okay? First of all, we need an actual sprite to display our player. So I'm going to right click on the player game object, go add component, and then go down to sprite. Now with the sprite, we have to provide it an image. So I'm going to click on these three little dots and select the sprite sheet tile source, okay? But then to actually display a sprite from that tile sheet, we need to define an animation, okay? I'm going to go over to our sprite sheet here, and inside of the outline, I'm going to right click on tile source, go add animation. Now, this isn't actually going to be an animation. If you do have an animated sprite sheet, then feel free to set that up. But for us, we're just going to have a static image. Now, we still need to define this as an animation because that's just how Defold works. If you want a sprite to be displayed, you need to basically define it as an animation. Now, I'm going to go down to the properties and change the ID of this to be player. Okay, and then what we need to do is specify a start tile and an end tile for this animation. But since we are only having a static image, these two things will be the same. So what we're going to do is go through this list, and essentially you'll see if I hover my mouse over a sprite, at the top left corner of the screen, it will basically tell us that tile's ID. So here we have 200, 209, 210, 211, etc. So I'm going to go through and have a look for a sprite that I want to use. And I think I will use this one right here, okay? And this sprite is 93. So I'll go to start tile, set that as 93, and do the exact same thing for the end tile as well. And there we go. So now I can save that, go back to my player collection. Then for that sprite component, if we go down to the default animation selection, you'll see we have the player here. I'm going to select that, and now there we go. We have our player sprite rendering. But there's one thing that's a bit strange, and that is our sprite's pretty blurry. Now, to get that crisp, pixel perfect pixel art, what we're going to do is open up our game project file here. Now, what we can do is go up to the search bar at the top left and simply type in the word filter. And you'll see we have our default texture min filter. I'm going to change both this and the second one over to nearest. Okay, just like that. If we save it and go back to our player collection, you'll see our sprite is now rendered crisply, which is very nice. Okay, so we have our player's sprite. Next up, we need to define a collider for our player so that they can be hit by enemies. So what we're going to do is right click on the player game object, add component, collision object. Now with collision object, we need to make sure that we are not making our player dynamic, meaning they'll be affected by gravity and can be pushed around. So if we select our collision object and go to properties, you'll see here we have our type. Now I'm going to change this from dynamic, which again basically has physics, which we don't want for our player, and change it over to kinematic, meaning we are going to control it purely through script. The next thing we need for our player is going to be a collision shape. So I'm going to right click on collision object, add shape, and go box. Now here we can simply modify the dimension, position, and rotation values here to basically fit the bounds of our player. Now this doesn't have to be exact, okay? This is only going to be a rough collider, so we can make it however big we wish. So I'm just going to make it something like this. Okay, we have our collider around our player now. And those are our two main components. Now, finally, we need a script for the player. So what I'm going to do is go to my player folder here where we have our player collection, right click on the folder, go new, and we're going to go over to where we have script, okay? Make sure it's just the normal script, not render script or GUI script, just script. And I'm going to call this player. And there we go. Now, let's get back to our player collection for now and add the script to our player. So I'm going to right click on the player game object, go add component file, and select the player script. Now that player script is going to be a part of this player game object, meaning we can actually then begin moving it around and access the different components that the player has. Okay, so that is our player all set up and ready to go. Now what we're going to do is go back into our game collection here, and we are going to right click on the collection, go down to add collection file, and add in the player here. So now our player is in our collection. So if we were to then run our game, we should see that our player is down here at the bottom left, okay? But of course, we want them to be in the center of the screen and zoomed in. So in the next lesson, we are going to continue working on our player by setting up their camera. In this lesson, we are going to continue setting up our player by first of all creating a camera for our player. Now, we aren't going to be setting up all the functionality of the camera just yet, because later on we're going to have our camera actually smoothly follow the player around. But for now, we'll just have it basically stuck to them and follow wherever they go. So to begin, let's go over to our player collection. So what I'm going to do is right click on the player game object and go add game object. I'm going to rename this one to be camera. And then as a child of this, I'm going to right click and go add component and go down to camera. Now this camera by default is going to be in perspective mode, which is typically what you would use for 3D. So I'm going to go and enable orthographic projection, which essentially just renders no depth, which is ideal for 2D games. Now, if I go ahead and press F5 to run the game, you should see that we don't see anything. And the reason why is because since our camera and our player sprite are on the same plane, so the same depth, it's not going to render. And the reason why is because of the near Z property here. Essentially, anything closer than 0.1 to the camera won't get rendered. This is just there for 3D where that might run into some issues with things clipping through. So I'm going to set this to 0. Since working in 2D, that's not going to be an issue. Now, if I run this again, here you'll see our player. but they're pretty tiny. So let's actually zoom the camera in, and we can do that by changing the orthographic zoom. Now, right now it is set to 1, meaning that 1 pixel on our sprite is equal to 1 pixel on our screen. But that's pretty small, so I'm going to set this instead to be 2. Now, if I run this, you should see that our player is a bit closer, okay? And you can, of course, modify this further if you wish. And there we go. Now, in the next lesson, we aren't going to jump into scripting our player just yet, because if we set up the player movement now, what's going to happen is our player is not going to appear like it's moving at all, because we have a black background with no frame of reference for us moving around. So what we're going to do is set up a simple little background tile map, okay? So let's get set up on actually creating a little tile map background for our game. So what I'm going to do is I am going to go to my levels folder here. I'm going to right click on it, go new, and we're going to create a new tile map. And I'm going to call this one game. Okay, so here we are inside of our game tile map. Now, to begin drawing in our tiles, we first of all need to go over to the tile source here and set that to be our sprite sheet tile source. Then you'll see this grid appear. We can then select the layer 1, which is going to be basically where we can draw in our tiles, and you'll see our mouse selecting a tile. Okay, now to paint in, we first of all have to hold down space or press space, and here is where we can then select a tile. So for example, I might select grass here, and then we can simply click and drag to draw it in, okay, just like that. So what I'm going to do is go ahead and just draw in a simple level for us to play with. And there we go. So this is just the little level I'm going to do for the game. Now what we can do is go back to our game collection. We're then going to right click on our main collection here, and we are going to create a new game object. I'm going to call this game object just tile map. Then we can right click on that and go add component file, select our tile map here and click OK. Now it has been added to our level, so we can actually see it being displayed right here, which is pretty cool. Now if we go ahead and press play, we should see it's here. But one thing you may notice, and that is our player is nowhere to be seen. So where are they? Well, our player and our tile map are being rendered along the same plane. Again, meaning just like with our camera, they are kind of being rendered on the exact same depth. And that results in issues if you want one thing guaranteed to be above another thing. So what we need to do is change our tile map's Z position. So if I go back over to my tile map here where we can paint it in, I'm going to select layer 1, and then down in properties, you'll see we have Z. This is essentially its Z position. I'm just going to set this to be -100. So no matter what, nothing is really ever going to be displayed behind it. Now, if I go back to our game collection, you'll see that nothing has really changed. But if we run our game with F5, there we'll have our player always rendering on top. Now, in the next lesson, since we now have a bit of a background to work with, we can set up the player movement. So let's get started on setting up our player movement. So what we're going to do is we're going to go into our player script, and let's start by cleaning up this default code. So first of all, I'm just going to remove the comments from the functions. We're going to keep the init function. We'll be needing that. This gets called once when the script is initialized. The final function, we can delete that. Update, we're going to have this. This gets called every frame. Fixed update, we can delete. On message, we definitely need this, so I'm just going to delete the comments there. On input, this is where we basically fetch all the inputs that are triggered. We're going to keep that. And on reload, we can delete. So these are the 4 built-in functions that we will be using. Now, to begin, we first of all need to define some variables which are going to keep track of our movement and mouse position. So up here inside of the init function is where we are going to define those. So I'm going to start by going self.mousepos equals vmath.vector3. Essentially, we are creating a variable called mouse pos, which is going to be a position, and we are assigning that to vmath, which is the math library, .vector3. A vector3 basically is a piece of data which contains an x, y, and z value. Then what we're going to do is we are going to create a variable called self.move equals false. So we're essentially going to have 4 different variables for move up, down, left, and right, and each of these are going to be either true or false. True if that button is currently being pressed. So I'll create the others here now, and there we go. Okay, now what we can do is then go down to the input function, or the onInput function, which gets called every time an input is triggered. And inside of here, we essentially want to set these variables based on whatever input we have received. So what we're going to do first of all is go self.mousepos.x equals action.x, which is essentially going to be the mouse's x position on screen. Same for the y, so self.mousepos.y equals action.y. That is how we can get our mouse position. Then we need to set the move up, down, left, and right variables to true if their respective action has been triggered. So here we are going to go if action ID, which is a parameter that gets sent over through the function, if this equals hash, and let's say move up, so the move up action, which gets sent over, then we are going to go self.moveUp equals true, okay? And then we can go ahead and do the exact same thing for the other 3 inputs. So we'll go else if action ID equals hash and move down. Then we'll go self.moveDown equals true, okay? And I'll do the exact same thing for the others. There we go for left and right. And then we'll go end, just like that. Okay, now what we need to do is actually make it so that this game object can receive those input calls, because by default, we do not have input focus. So up here inside of the init function, we are going to post a message to the game object that this player script is attached to. So I'm going to go msg.post. The receiver is just going to be full stop, which is basically a shorthand for saying this script's game object. And the message ID is going to be acquire input focus. So now those onInput events will be sent over to this player script. Okay, so we now have the player's input set up. What we then need to do is actually use this to move our player around. So how do we do that? Well, what we're going to do is we are going to define some more variables here. First of all, inside of init, we are going to create a variable self.velocity, which is going to be essentially the amount of pixels we want to move in and what direction per second, equals vmath.vector3. Because remember, we can move along the x and the y axis, so we need that as a vector. And then we also need a local variable outside of the function. So I'll go local, and I'm going to call this one move speed. Move speed equals 150. Now, this right here is a variable that's different from this one, okay? Essentially, when we go self dot and then a variable name, this is a variable that we are creating for the instance of this player script, meaning that if we were to have multiple different player scripts, we could have a different move up variable for each of them. Whereas up here, where we are creating a variable, this essentially means that this variable is going to be the same across everything. All right, so move speed 150. Then what we can do is down inside of update, we are going to first of all define our velocity. So at the start of each frame, we want to basically set our velocity to be 0. So I'm going to go self.velocity equals vmath.vector3, essentially resetting it to be 0 on the x, 0 on the y, and 0 on the z. Then what we can do is basically check to see if self.moveUp. So if the move up variable is equal to true, then what we're going to do is we are going to go self.velocity.y equals self.velocity.y plus 1. So we are essentially setting our y velocity to be pointing upwards. Now, what I want you to do is then do the exact same thing. So I'm going to put an end here. We are then going to go if self.moveDown equals true. Then what do you think we're going to do? Yes, we're going to go self.velocity.y equals the velocity -1. Now, as a bit of a challenge, I want you to go ahead and do the same thing for moving left and right, modifying the x velocity. Alright, so I hope you had a go at that challenge. Essentially, what we're going to do is we're going to go if self.moveLeft equals true, then we'll go velocity dot x equals velocity -1, okay? Because if we're moving left, we want to go into the negatives along the x velocity, okay? And then finally, let's just copy and paste this here. If move right is true, then we are going to add 1. So the reason why we are not just setting, for example, here the velocity of the y to be 1, here to be -1, here to be -1, etc., is because what would happen if we were to press both the left and the right movement keys at the same time? If we were to check them sequentially like this in if statements, that would mean that one of those directions has priority over the other. Whereas if we do it this way, essentially, let's just say we are pressing both A and D, both left and right together. Well, we're going to subtract 1 from the velocity, but we are also going to add 1 to the velocity. And this basically negates that input, okay? It'll mean that we do not move at all left or right. So then what we need to do after we get our velocity is we need to basically set our input variables here to be false because we have used those inputs, we no longer need them. So here I'm going to go self.moveUp equals false, and then we want to do the exact same for down, left, and right, okay? Again, the reason why we are setting these to false is because if we were to press the W key to move up and then let go of it, well, move up would still be true, okay? So we need a way of basically setting these to be false once that has been used, and we're essentially doing that each frame. Now, before we continue with this function, we need to make sure that our velocity has a length greater than 0 because we are going to be doing a mathematical operation known as normalization. Essentially, we are going to get our velocity and we are going to modify the values so that the total length of every axis added together is equal to 1. And the reason why we do this is because when it comes to movement, we of course don't want to move at 1 pixel per second. We want to move at 150. And the way to do that is by normalizing the vector so it has a length of 1 and then multiplying that by 150. So for example, if our vector was pointing to the right hand side, it would be 1 on the x, 0 on the y. Multiply that by 150, we are then moving 150 on the x, okay? So that is how we essentially modify our speed. So to do the normalization though, we cannot have a velocity with a length of 0. Otherwise, that is going to result in divide by 0 errors. So for this, we are essentially just going to check if vmath.length of our velocity variable equals 0, then we are going to return. Essentially, we are going to end the function here and not do anything else. Otherwise, if the length of that velocity variable is greater than 0, then we can normalize it. So here I'm going to go velocity equals vmath.normalize, and here we just give it our velocity like so. Okay. Then what we can do is multiply our velocity by our move speed so we can actually move fast. So here I'm going to go self.velocity equals our velocity multiplied by the move speed. And then finally, we can add this velocity to our position. So to do that, we first of all need to get our player's position. So I'm going to create a local variable here called pos, and this is going to be equal to go, which is shorthand for our game object that the script is attached to, .get position. We are then going to add our velocity to our position. So pos equals pos plus self.velocity. And then we can go.setPosition, and we're going to give that the pos variable. All right, and we do actually have an error before we press play, and that is up here where we are doing our velocity calculations. We actually need to add in the .y, the .x, and the .x here. I mistakenly forgot to add those in. But now if we go ahead and run our game with F5, we should see that we can move our player around. And they are moving very, very quick. Now, why is that? Well, because what we are doing here is adding our velocity to our position every frame. Now, our velocity is a definition of how many pixels we move per second, but we are moving that many per frame instead. So what we need to do is shrink our velocity down or convert it into a per frame calculation rather than per second. And we can do this by going multiplies by dt. Now, what is dt? Well, dt is a parameter that gets sent over with the update function, which stands for delta time, essentially the time between frames. Now, this is a very, very small number. So if you're running your game at 200 frames per second, this is going to be something like 0.002 or something like that, okay? Something very, very tiny. And what that does is it converts our velocity from a per second calculation to a per frame calculation. So we are no longer moving at 150 pixels per frame, but 150 pixels per second. So if I run this, you will now see that when I move, we are moving at a consistent 150 pixels per second. We are going to be setting up something that isn't necessarily going to be vital at this very moment, but it is something that we are going to be needing for the future. And this is going to be getting our world mouse position. Because right now, this mouse position variable, which if we go down to the onInput function, here we are setting this right here. Now let's go ahead and actually print this out. So if I go to my update function and print out the mouse position variable, and then we run our game and check the console, you'll see here that it gets printed out, okay? The further to the left of the screen I go, the lower that gets, and the further to the right, the higher the X value goes, same with the Y. But this that we are seeing right here, that vector, is not in terms of world coordinates, but rather screen coordinates, okay? Our player at the moment is standing at 0, 0 in terms of world coordinates. Yeah, if I put my mouse over the player, you'll see our mouse position is around 480 by 300. The 0, 0 position for our screen is down here in the bottom left corner, okay? But we are going to be needing the world position of the mouse for two things: for deciding which way our player needs to face, so they're always going to be facing the mouse, and for then shooting our projectiles, okay? When we shoot our projectiles, we want them to be shooting towards the mouse. For both of those things, we need our world mouse position. So how do we actually convert over to that? Well, what we're going to do here in this lesson is just that. So at the top of our update function here, we are essentially going to go get our world mouse position, okay? So let's see how we can do that. First things first, what we need to do is get both our screen width and screen height. So I'm going to create a local variable. I'm going to call this one screen width. And if I go comma, I can define another variable here called screen height. And then if I go equals window.get size, what this is going to do is it is going to return the width to the first variable and the height to the second variable, okay? So these are going to get the width and the height of our screen in pixels. Then what we need to do is with that, get the center of the screen, because remember, like I said, our screen behaves kind of differently in terms of coordinates from our world. Our world starts at 0, 0 in the center, and it goes into the negatives to the left and down and positive to the right and up, whereas our screen starts at 0, 0 in the bottom left corner. So to get the central position of our screen, what we need to do is essentially divide the width and the height by 2. So here I'll create a variable called a local screen center equals vmath.vector3. For the x, it is going to be the screen width divided by 2, and the y is going to be screen height divided by 2. And then the z, we're just going to set to 0. Okay, so that is how we can get the center of our screen. Now we also need two more things, and that is going to be our camera's position and our camera's orthographic zoom. The reason why is because to calculate specifically where our mouse is in the world, we need to divide our final calculation by the zoom level. So here I'll go local camera pos, and before we actually define this, let's go back into our player collection and detach our camera from the actual player game object. So I'm going to select the camera game object and drag that over collection. So now our camera and player are separate, meaning if I press play, you'll see that my player doesn't actually have the camera following them anymore. And this is just going to be important for when we set this up. Now let's go back to our player script and we'll go camera pos equals go.getPosition. We can enter in the URL for the camera, which is going to be camera like so. Then we also want to get the camera zoom. So local camera zoom equals the camera.get orthographic zoom. And the camera that we want to access is going to be the camera game object. And then we want the camera component as a child of that. So we'll go hashtag camera then. And there we go. Now what we can do is go ahead and do our world mouse position calculation by going local world mouse pos equals, and this is going to be a bit like this. Okay, we're first of all going to have our square brackets like this, go self.mouse pos minus screen center, then divide that by the camera zoom, and then add the camera pos. So this right here is the calculation needed to convert a screen coordinate into a world coordinate with a moving and zooming camera, okay? We also then want to set the Z position of this to be 0, so world mouse pos.z equals 0, and there we go. Now if we go ahead and print this out, world mouse pos, let's go ahead then and run this. What you'll see is that our mouse position is now in world coordinates. So if I hover over the player, you'll see it is about 0. And as I move it away, it is going to increase based on whatever coordinate in the world we are pointing at. Now what we can do in the next lesson is make it so that our sprite is going to flip to face the mouse position. In this lesson, we are going to be working on flipping our player sprite based on the mouse position. So if our mouse is over to the left, we aren't going to flip our sprite because it's already facing to the left. Whereas if our mouse goes over to the right, it is then going to flip its horizontal state. So to do this, let's go to our player script, and underneath where we are getting our world mouse position, we need to create a new variable, which is going to be our mouse direction. And let's actually define that up here. So where we define our variables, we'll go self.mousedir for direction equals vmath.vector3. And this right here is going to be the direction relative to the player that our mouse is going to be pointing at. So down in the update function, I can go self.mouse direction equals, and this is going to be equal to vmath.normalize, and we're going to normalize the world mouse position subtracted by the go.get position. Okay, so here we are essentially subtracting our position from our world mouse position, and then we are normalizing that. So now this is basically going to be a direction relative to the player that the mouse is pointing. And then to flip the sprite, we can do that right here. So we'll go flip sprite. What we're going to do is we're going to go sprite.set h flip, so set horizontal flip. We need to give it a URL, which is going to be our sprite URL. And to do that, we can simply go hashtag sprite. Remember, the hashtag essentially means we are accessing a component attached to this game object, and that component's ID is sprite. So if we go to our player collection, you'll see we have our player game object, and we are accessing the sprite component, okay? So then for flip, this is going to be either true or false. So I'm simply going to create a condition here, which is going to be our mouse direction.x, and then we'll go greater than 0. So if our mouse direction.x is greater than 0, meaning the mouse is on the right-hand side, it's going to be true. Otherwise, it will be false. So now if I run this, we should see that our player is going to flip its left and right direction to look at the mouse, which is very cool. Okay, so we got that all set up. Now, in the next lesson, I think we should probably be setting up our camera because right now our camera is kind of static. We did have it following the player before, but to have it set up for the future, we really need our camera smoothly following our player around, okay? So that is what we're going to be working on in the next lesson. In this lesson, we are going to be setting up our camera follow script. Essentially, this is going to make it so that as our player navigates around the level, the camera game object, which is also here in part of the player collection, will follow. But it's not going to snap to the player's position. Rather, it is going to smoothly transition to them to basically make the movement feel a bit nicer. And then the second part of the camera follow system is going to be clamping the camera's position, essentially making it so that the camera cannot go beyond the bounds of our level. So to begin, let's go ahead and create a new script. I'm going to go down to my player folder, right click on it and go new, script, and I'm going to call this one camera controller. Just like that. Now, inside of this camera controller, we are going to keep the init function, delete final, keep update. We're going to delete fixed update, keep on message, and delete the final two. Okay, so the init, update, and on message are the three functions that we're going to keep from the default list. Now, this camera controller script, if we go over to our player collection, we can select the camera game object, which has that camera component inside of it, and we're going to right click on it and go add component file, and we're going to attach that camera controller script like so. Now, back inside of our camera controller, what we're going to do is we are going to, first of all, go to the init function and create a variable, which is going to be called follow pos. Essentially, this is going to be the position that the camera is going to try and get to each frame. It's going to be moving towards this position. So we'll make it a vmath.vector3. And as you may have guessed, this follow position is indeed going to be the player's position. So how are we actually going to set this? Well, the way we're going to set this is every single frame, the player script is going to send a message over to the camera controller, essentially telling it the position to follow. So here in onMessage, we're going to go if the message ID is equal to, and the message we can call, for example, follow. And then if that is the case, we are going to set our follow position to be the messages follow pos. Okay, so that follow pos is going to be the data we'll send over. Now let's set this up now so we can actually get it working. So let's go over to our player script, and inside of our update function, let's just go down here at the top somewhere, and I'll create a little comment called camera follow. And here, essentially what we're going to do is we're going to post that follow message. So msg.post, and here we want the receiver URL to be our camera controller script. So let's go to our player collection. And if I select the camera controller script right here, you'll see we first, from our player object, have to access the camera game object, then the camera controller component. So to do that, we are simply, as the receiver URL, going to go camera, hashtag camera controller. Then the message ID, remember that one is follow, and then we can send over some data. So I'm going to have an opening and closing squiggly bracket right here. It's going to go to a new line to make it a bit neater. And we're going to define the follow pos data to be equal to our player's position. So .go.get position, and there we go. So now if we go to the camera controller script, inside of update, let's just quickly go ahead and print out self.follow position just to see if it works. I'll bring up the console here, press play, and as you can see, as the player moves around, that follow position is being changed to be the player's position. Okay, which is great. Now to actually set this up, let's first of all make it so that the camera is just going to follow the player's position directly with no smoothing. So for that, we need access to the camera's position. So local pos equals go.get position. We then want to set our position to essentially be the follow position. So pos equals self.follow pos. And then we want to set our position again. So go.set position, and we'll set that to be pos. Now, if I run this, we should see that the camera is going to be the player's position, okay? So the camera is going to follow the player around. But as you can see, it's kind of snappy. We do have a bit of a weird offset when the player moves, but we want to make it so that the camera is going to smoothly transition to the player. So to do this, we are going to use what is known as linear interpolation, okay, or lerping. Essentially, what lerping does is you give it a current value and then a target, and then the amount that you want it to essentially interpolate between those two values. And we can adjust that interpolation value to define how quickly or how slowly the smoothing is. So here where we go pos equals self equals the follow position, we're instead going to make it equal to vmath.lerp. And lerp here, we have a t, n1, and n2. T is essentially the delta. For this, I'm going to go 15 times dt. Now we're multiplying this by delta time because we want this to be frame independent. And 15 is just a random number I'm putting in. We can, of course, adjust that later on. We then enter in the from position as n1, which will be pos, and the to position, which is going to be self.follow pos. So the position that we want to get towards. Now, if I run this, you'll see that the camera is going to smoothly transition and follow the player, which looks nice. Now, we can make this effect be a bit more smoother by lowering the number. So if I make this 5, you'll see that the camera is going to take a lot longer to catch up to the player's position. But I think 15 is a good number here. So there we go. That is how we can set up our cameras following. Now, what we're going to do next is work on setting up the boundary, essentially make it so our camera cannot exceed the boundary of our level, so we don't see any blackness beyond our tile map. So the way we're going to do this is by essentially clamping our camera position, and to do this, we are going to need a vital function, and that is a clamp function. Now, a clamp function, essentially, you give it 3 values. You give it the value you want to clamp, a minimum, and a maximum. And basically, that function will return that value that you gave to it clamped or restricted between the minimum and the maximum. So I'm going to create that function here, just above update. So I'll go local function, I'll call it clamp, and then the 3 parameters we're going to have is going to be value, min, and max. Now, inside of this function, we essentially want to check to see if the value is less than the minimum. Then what we're going to do is we're going to return the min. Else if the value is greater than the max, then we are going to return the max. Otherwise, we can safely return the value that was already given to us, okay? So you can see here, we're essentially creating a function that restricts a value from getting too low or too high. And inside of update is where we will then put that into action. So I'm just going to add a little comment here, which just goes camera follow. And then down here, we are going to go camera boundary, okay? Now, before we actually define the code for this, we need to know what our boundary is, okay? So how far can our camera actually go? Well, to do this, I'm going to go into our game here. I'm going to select our player just because it's a little visual marker, and I am going to move them over to the leftmost boundary here, okay? So this is going to be the furthest the camera can get in terms of its left-hand side. So what we're going to do is then look at the X position, which is minus 480, okay? So 480 is going to be the furthest left that the camera can go. And thus, since this is a square, it will also be 480 for all the other directions. So what I'm going to do is I'm going to go to the top and create 4 new variables. I'm going to create a variable called left boundary, which is going to be equal to minus 480. We then want one for the right, up, and down. So here we'll go right, which is going to equal positive 480. We then have the up boundary, which is going to equal positive 480. And then we also have the down boundary, which is negative 480. Now, if you did have a rectangular level, then these values will be different. But take those measurements yourself just to make sure. Okay, so we have our boundary variables here. Now down inside of update, there are going to be a number of different steps we must follow before doing the camera boundary, okay? So step 1, what we need to do is get the center of the screen, okay? So here we'll go get screen center. Then what we're going to do is we are finally going to clamp the position, the camera position, okay, to the boundary. So these are the 2 steps we're going to do. And in the next lesson, we'll go through them. So in this lesson, we are going to start by getting the screen center. Now, why are we doing that? Now, the reason why is because we aren't going to be clamping the camera based on its position. And I'll show you what I mean by that. So if we go out to our game here and we select our camera game object, we want to make it so our camera cannot go beyond the bounds of our tile map. But if, for example, we clamp our camera's position directly based on those bounds, then our camera, for example, will not be able to go beyond this X position. But since this is the center of our camera, our view would then look something like this, okay? Half our screen would be in our level, but the other half would still be outside of it. Now, we could, of course, find a value in here to clamp the camera in, but that would then make it so that different resolutions would stop at different positions, okay? So what we need to do is get the center of our camera, and that will allow us to automatically then offset from the left-hand side, for example, to clamp it so that the left-hand side of our camera will always bump up against the very edge of our level, no matter the resolution, okay? So that is why we need to get the center position, because we'll be subtracting it and adding it to the boundaries, okay, to get our new adjusted boundary with that, I guess you could say, margin in place. So to get the screen center, we first of all want to get the screen width and height. Now, we've already gone ahead and done this before in our player script. We're going to create 2 local variables, screen width and screen height, and these are going to be equal to window.getSize. Then what we want to do is get our camera's orthographic zoom. We've also done this before, so we'll create a local variable called zoom, and this is equal to our camera get orthographic zoom. The URL for that is simply #camera, because remember, this script is attached to the camera game object, which has the camera as a component. So we simply go #camera for that URL. And then for the screen center, we can go something like this, equals vmath.vector3. Now for the X, we're going to go screen width divide by 2 divide by zoom. Now we're dividing by the zoom because the screen width is going to be the same no matter the zoom level. So if the camera zoomed very far in, that screen is still going to have the same width in pixels. So we divide by zoom to get a sort of world camera width. Okay, so this is essentially going to get the camera's center as a world position. Then for the Y, we're going to go screen height, divide by 2, divide by zoom, and then 0 for the Z. Now, if you're wondering why we're dividing by 2, that is of course because we want to get the center of the screen, so half of the camera's width and height is going to be a point right in the middle. Now that we have that, we can go ahead and clamp our camera's position. So I'll show you how we do that. Essentially, we go pos.x equals clamp. Now, we're calling that clamp function we created in the previous lesson, and we want to give it a value, which is going to be pos.x. Now, the minimum, this minimum is essentially going to be our left boundary plus the screen center along the x-axis. So I'll show you here. So we'll go left boundary. And before we do that, let's actually have a look at if we just give it the left boundary and the right boundary, okay? So we're clamping our X position between the left and the right. And then let's, of course, set our camera's position to be that new pos. Okay, so now if I go ahead and run this, we'll see this in action. So the camera follows as usual, but you'll see that if I go all the way over to the left here, the camera stops at the left boundary. And this was the issue I was talking about before. So what that screen center offset does is essentially makes the minimum clamp value, this boundary, plus the screen width, or plus half the screen width. So here, what we can then do is go left boundary plus screen center.x, and then the max is going to be the right boundary minus screen center.x. Now, if I go ahead and run this, you should see that again, if we go over to the edge, the camera now stops at the very edge here on the right-hand side. Same thing, or on the left-hand side, and same thing if we go over to the right. Now, let's do the exact same thing, but for the Y. So I'll go pos.y equals clamp. Pos.y for the value. The min is going to be the down boundary plus the screen center dot y, and the max is going to be the up boundary minus screen center dot y. So now, as you can see, we can have our player move around the level, but the camera will never exceed the bounds of said level. Okay, so that is how we can set up a nice camera controller script inside of Defold for our game. In this lesson, we are going to start working on our projectiles. Now, these are the objects that the player is going to create and then launch out towards the mouse position. Now, a projectile is going to be represented by a game object, and then we are going to use factories to essentially create these projectiles from the player game object and then shoot them out. So let's go over to our entities folder, right click, go new, and we're going to go up to where we have game object right here. I'm going to call this one projectile. And inside of here, we need to create a few components. First of all, a sprite to actually see what we're looking at. So I'll go add component, go down to sprite. We'll set the image here to be the tile source. But then we need a default animation. Now for this, let's go over to our sprite sheet and we are going to go to the outline, right click on tile source, go add animation, and we are going to call this one projectile. Just like that. Now, what actual sprite are we going to use for our projectile? Well, I'm going to probably choose a fire sprite. So one something such as down here. There's plenty of them. Depending on your sprite sheet, of course, feel free to go ahead and figure that out. So I'm going to set the start tile here to be 1903. And the end tile to also be 1903, which is a sort of flame sprite. Back inside of our projectile, we can then set that default animation to be that right here. But what you'll notice is that the sprite is a bit offset. So what we're going to do is simply just move it so that the sprite image itself is in the middle, not the origin of that component. Next, let's go ahead and add in a collision object so we can actually have the ability to detect collisions. And on this collision object, we are going to change its type from dynamic to trigger, essentially meaning that this object is going to be controlled by the script, and it is not going to be a collider in the sense that it's going to bump up against things, but rather it is going to go through and detect triggers, okay? Sort of like an overlap. Let's right click on collision object, add shape, sphere, and we can then resize this to see something such as that right there, 10. Okay, so we have our projectile pretty much set up. Now we just need to attach a script. So in entities, we're going to create one more asset, and that is going to be a script called projectile. And then of course, we can go ahead and attach that as a component. So right click on game object, add component file, go down to projectile, and okay. And there we go. Now, over inside of our projectile script, we are going to keep the init function. So I'm just going to remove the comments, delete final. We can also then keep update, delete fixed update, keep on message, and then delete the other two here. Okay, and there we go. So these are the functions we are going to be using. Now for our projectile, we also want a variable, so local, and I'm going to call this one speed, and this will be 200. So this is essentially how many pixels per second is this projectile going to move at. Now inside the init function, we can set up some variables. So I'm going to then create one called move direction, which is going to be a vector direction. So vmaf.vector3. This will be given to us when the player spawns the projectile, basically then telling it which way it should move. And then another variable called timer, which is going to equal 2. And this is going to be the lifetime of the projectile. Essentially, it is going to survive for 2 seconds. Now what we're going to do is actually make it so our player can spawn these projectiles. Now to do this, we're going to go over to our player collection, right click on the player game object and go add component and go over to where we have a factory. Now a factory is a component that essentially can spawn in game objects. I'm going to rename this to be projectile factory. So projectile factory like so. And the prototype is essentially the game object it is going to spawn in. So I'm going to open this up and select our projectile. Now, if we go inside of our player script, we can set it up so that whenever we left click, we are going to shoot. Now, to do this, I am going to create a new function. So just below update here, let's create a new function. So local function, and this is going to be called try shoot. And it's going to have self sent over, of course. So the try shoot function, essentially when we left click with our mouse, this is going to call. And the reason it's called try shoot and not just shoot is because this function is going to be called every time we press the left mouse button. It is then going to check to see if we have the ability to shoot. So has enough time elapsed since we last shot? If so, shoot, otherwise don't. So let's connect this function up to our left mouse button. Now, if we go down to the on input function, remember on our input map, we had that shoot input. So here I'm going to simply go if action ID equals hash shoot, then we are going to call try shoot, just like that. Okay. Now inside of try shoot, let's print out the word shoot to just make sure it works, and then run this. Okay, there we go. Let's pop open the console here so we can have a look. And now if I go and left click, you'll see shoot. And every time I press it, even when I'm holding down my mouse, you can see shoot is being called many times, up to a couple hundred at the moment. But we don't want to be shooting every single frame, okay? That is going to create a lot of projectiles and a lot of lag. So we are going to make it so that the player can only shoot perhaps 10 or 5 times per second. So up here inside of the init function, we are going to go ahead and define those variables. So first of all, we need a timer. So we're going to create a variable called timer, which will be equal to 0. And this is essentially just going to count up in seconds. The reason why is because whenever we shoot, we are going to basically keep track of the last time that we shot, and then whenever we want to shoot again, we are going to make sure that the time between now and the last time we shot is greater than our shooting rate. Okay, so I'm going to create a self variable here called last shoot time equal to 0, and then also a variable called shoot rate, which is going to be equal to 0.1. Okay, 0.1 meaning we can shoot every 0.1 seconds. Now, down inside of update, I am simply going to make it so that the timer is going to increase by 1 every second. So here we can go timer equals timer plus dt, which is delta time. So basically, if we increase by dt each frame, it's going to be basically going up second by second. Now, inside of try shoot, we want to make it so that if we have shot within the last 0.1 seconds or whatever our shoot rate is, then we return. So I am simply going to go if the timer minus the last shoot time. If that is less than the shoot rate, then we are going to return, okay, like that. Now, otherwise, what we're going to do is we're going to print out shoot again, and we're also going to set our last shoot time to be equal to the timer's current value. Now, I'm going to pop open the console, I'm going to press play, and let's see what happens when we try and shoot. So now you can see that that shoot print, which it's pretty hard to see down there in the video, but it is going up a lot slower. It is going up once every 0.1 seconds. So we are now shooting at a consistent rate, not every frame. All right, so in the next lesson, we are going to make it so that instead of printing out shoot, we are instead going to create a new projectile, set its position, and then shoot it off in our mouse direction. So let's set it up now so that when we shoot a projectile, we aren't just printing out a line of code, but rather we are spawning in a new projectile. So inside of the try shoot function, what we're going to do is I'm going to start off by creating a local variable called proj, which stands for projectile. And this right here is going to be equal to factory.create. Now with this, we basically need to give a URL for our factory. Now, if we go to our player collection, you'll see that the factory is a component of player. So we simply need to go hashtag projectile factory. So here we'll give that URL, projectile factory. And if we add a second parameter, we can actually give it a position. So I'm going to set it to be our player's position. So go.get position, like so. Now let's see if this is going to work. So we'll run this and we can left click. And as you can see, each time we left click, it is going to spawn in a brand new projectile, which is pretty cool. But at the moment, you'll notice that the main thing, we don't actually have these projectiles moving. They're kind of just sitting there in space. So let's make it so that our projectiles can actually begin moving in the direction of our mouse. Now we are going to do this by sending a message over to the projectile, and this message is going to have the ID of set direction, and we'll be sending over our mouse direction vector. So for this, I'm going to go msg.post. The receiver is going to be the projectile we just spawned in, so we'll use that proj variable. The message ID, we can define this as set direction, our own custom little message. And if we add a comma, opening and closing squiggly brackets, we can then define some properties that we want to send over through the message. Now, we're only going to send one, and that is going to be the move direction. So we'll go move equals our mouse direction, just like that. Now, let's make it so that the projectile can then actually receive this message and then run code respectively. So over inside of our projectile script, what we're going to do is go down to the onMessage function, which gets called whenever a message has been sent to the projectile. And we're going to check to see if the message ID is equal to that set direction message. Whoops, set direction like so. Then what we're going to do is we are essentially going to set our move direction variable that we have defined here in init. So we'll go move direction equals message.move direction. Just like that. Okay. So we've set our move direction. Now we actually need to move our projectile along this vector. Now, we've done movement already with our player, so we should be able to do that. So we simply, first of all, in the update function, want to get our current position. So we'll go local pos equals go.getPosition. Then we want to increase our position in the move direction at a rate of speed. So here we will go pos equals pos plus the move direction times move speed, times speed, times dt for delta time. And then finally, we can set our position to be the new one. So go.setPosition pos. Okay, let's now run this and see if it works. So as you can see, every time I shoot now, we are basically having the projectiles launch out in that direction. But there's one more thing that we need to do to finalize our projectile shooting, and that is not collision detection just yet, because we don't really have any enemies in the game, but rather setting it up so that these projectiles destroy after a certain amount of time. Because if I shoot and then follow this projectile, you'll see it kind of just keeps on going on forever. Now, the big reason why we don't want that to happen is because of performance, okay? If I'm here shooting all these projectiles around, they are going to keep on flying out forever, okay? And we don't want that. We want the projectiles to delete themselves after a certain amount of time, which, as you can see here, we have set a timer variable to be 2. Now, down here inside of update, what we're going to do is every frame basically subtract from timer, so it goes down in seconds. So here we'll go self timer equals the timer minus dt, and then we'll check to see if the timer is less than 0, then we want to destroy this object. So we can go delete, and there we go. So now if we run this, you should see that when I shoot a projectile and after 2 seconds they will be deleted, okay? So they're no longer going to take up memory space if they keep on being shot outwards, because otherwise, you know, that's going to take up a lot of space in memory, and Defold also has issues when you have too many sprites being rendered at the same time, so we aren't going to run into any of those issues either. Now, this is where we are going to leave our projectile script for now. In the future, once we create our enemies and our damage system, we will then return here to implement the ability to actually damage enemies. But for now, that is everything with our projectiles done. And in the next lesson, I think it's going to be a great idea to start on creating our enemies, okay? These little creatures that can then chase after and attack the player. Okay, so let's get started on setting up our enemy. Now, for our enemy, what we're going to do is we are going to go over to our entities folder, right click, go new, and then we are going to go over to game object. And this, of course, is going to be called enemy. Now, with our enemy, we, of course, want to then give it a sprite. Okay, so let's go ahead and create a new sprite component here. Set the image to be that sprite sheet tile source, and then we need to give it an animation. So I'm going to go over to my sprite sheet tile source here, and I'm going to find a nice little sprite for the enemy. I think this spider right here is going to be a nice one, so that's number 286. So I'm going to right click on tile source in the outline, add animation. I'm then going to call this one enemy. And I'm going to set the start tile here to be 286 and the end tile to be 286 also. So there we go. Now, if we go back to our enemy game object, we can go ahead and set the default animation to be enemy, and we now have our sprite. Okay. Just like with our projectile and our player, we then want to go ahead and add in a collision object. This collision object is going to be of type kinematic because we're going to control all of its movement inside of this script. And then we want to add a shape. Now I'm just going to add a simple sphere shape for our enemy and make the diameter about 30 right there. Okay, so we have our collision. Now let's add in our script. So I'm going to go to the entities folder again, right click and create a brand new script. This one here is going to be called enemy, of course, and then we can go ahead and attach it to our game object. So add component file and the enemy script right here. Okay, now before we continue, let's go over to our game collection and add an enemy in so we can actually test it out. So right click on collection, add game object file, enemy, okay. And we're just going to move it over here. So now if we go ahead and play our game, you should see that we have the enemy in here. Now we need to work on the enemy's main function, which is going to be chasing the player. So the way we are going to do this is basically have it so that the enemy knows where the player is at all times, and then they are going to actually then begin moving towards them. And when the enemy gets within a certain range, maybe about this close, they will stop moving and begin attacking. So let's go ahead and implement that. So inside of the enemy script, we are going to keep the init function, delete final, we are going to keep update, we are going to delete fixed update, keep on message, and delete the other two. Okay, so these are the only three functions we're going to start with. Now we can define some properties or some variables for the enemy. The first one is going to be for the enemy's move speed, so how fast are they going to move. We'll set it to be at 50 pixels per second, so of course slower than our player. We then want a variable for our attack range. This is going to be the pixel distance from the player at which they will stop and begin attacking. So I'm going to set that to be 40. Then we're also going to have an attack rate, which is going to be equal to 0.5. So every half second they can attack. And then finally, we need a way of the enemy actually knowing what to chase after and what to attack. And we're going to do that with a game object property. Now, a property is essentially a variable that we can expose inside of the properties window here. So if we select our enemy script, you can see we have path, ID, URL. These are all things we can modify. We can add our own custom property to basically be displayed here, where we can then reference the player's URL. So inside of the enemy script, I'm going to go ahead and set this as go.property. Now make sure this is outside of a function. We need to give it a name. I'm going to call this variable target. And the value is basically going to be the default value and data type. So we want this to be a URL. So I'm going to set this to be msg.url. Now, if we go back to the enemy game object and select the enemy script, you'll see we have a target field here where we can give it a URL. Now, the URL for our player is, if we go over to the game.collection, it is going to be the player collection. Okay, so we'll write down player/player for the player game object. Okay, so we need to go into the player collection, then into its game object. So this target URL is going to be /player, player. Okay, and there we go. So now the enemy knows what and where the player is. Now what we need to do is make it so they chase after them. So back inside of our enemy script, what we're going to do is first of all initialize with some variables. We're going to start by setting a velocity variable. So velocity equals vmath.vector3. We also want a variable to keep track of the player position. So player position equals vmath vector3, and we then also want a player direction. So this is going to be the direction from the enemy that the player is, essentially the direction the enemy is going to move at. We then also want another variable for the player distance. This is going to be how far away the player is, and by default we'll set this to just be a very high number, just so it doesn't automatically deal damage when the game initializes and checks to see that, it might be 0, for example. And that is everything we're going to have for now. So down inside of update is where we can then implement the moving. So the first thing we need to do is essentially fill in these variables. We need to basically fill them with data. So we need to get the player's position, the direction, and the distance. First of all, let's get our own position. So I'll create a local variable called pos, which equals go.getPosition. Then we can set the player's position by going self.playerPosition equals go.getPosition. Now, go.getPosition isn't only used to get your own game object's position, okay? We can also enter a URL as a parameter, and it will get that object's position. So here we can enter in the target variable. Now, self.target is essentially referencing this property that we defined up here, okay? So make sure that the variable name is the exact same one you're using down here. So that is going to get our player's position. Let's then get the player's direction. So for the player direction, what we're going to do is we are going to basically get our player position minus our enemy position. So self.playerPosition minus pos. But this vector is going to be a different length depending on how far or how close the player is. Whereas we want this to have a set length of 1. So we're going to normalize this by going vmath.normalize. And then we're going to plug in that vector calculation inside of the normalize function. Next, what we're going to do is calculate our player's distance, and we can simply do this by calculating the length of this raw direction calculation, okay? So here we are normalizing it, so we can go self.player distance equals vmath.length, and the length is going to be of this specified vector, which is self.playerPosition minus our own position. And there we go. That is how we can calculate these 3 different things. Now, next, what we're going to do is actually begin moving the enemy. So to do this, we can simply go our own position equals pos plus the player direction, so self.playerDirection times by move speed times by delta time, and then of course we want to set that position as well. Now if we run this, we should see that the enemy is going to move towards the player over time, which is pretty cool. And you may notice how they're going to keep on moving until they reach the center of the player. But we want to make it so the enemy stops about 40 pixels away and begins attacking. So that is what we're going to be working on in the next lesson. Alright, so let's continue on with our enemy script, making it so that the enemy is not going to move beyond or closer than their attack range, which is 40 pixels. So for this, let's go to the update function just before we are moving towards the player, and we are simply going to check to see if the player's distance is less than the attack range. If so, then we are going to return and end the function here. So I'm going to go if self.playerDistance is less than or equals to the attack range, then we are going to return, okay? Essentially, we're going to end the function here and not move towards the player. So we are only going to move if we are above the attack range. Now, let's run this and see if it works. So you can see the enemy chases after the player here, and when they get less than or equals to 40 pixels, they stop moving. If it goes beyond, they keep moving again. Okay, so that is how we can set up the ability for the enemy to run and then stop. Now let's make it so that the enemy can begin attacking the player. We're not going to implement damage in this lesson, but we are going to implement the ability for the enemy to essentially trigger an attack. So the way this is going to work is essentially we are going to create a new function called try_attack. So just above the update function, I'm going to create a local function called try_attack, carry over self. And in this side of this function, we are going to do something very similar to how we set up the player's shooting. Essentially, the enemy can only attack every 0.5 seconds. So with that, we also need another variable, which is going to be our last attack time, which will equal to 0, and also a timer variable, which will be equal to 0. Now down here inside of try_attack, we're simply going to go if the timer, which we're going to increase over time very shortly, minus the last attack time is less than the attack rate, then we are going to return, okay? Because otherwise, not enough time has elapsed between attacks. Otherwise, we're going to print out, and let's just say attack, okay? Now let's set up the last attack time. So here we'll go self.lastAttackTime equals self.timer. And then for the timer, we can simply just go self_timer equals the timer plus delta time. So now if I press play, you'll see if I open up the console here, we should see that nothing is happening. And of course, that is because we need to actually run the try_attack function. Down an update, I'm just going to go here and go try_attack. Okay, it doesn't really matter where we put it, just make sure it is before the return condition here. So if I run this and then open up the output, we should see that we are getting an attack every 0.5 seconds, which is good. But you can see that the attacks are also being called when the enemy is away from the player. We only want them to attack when they are close within range here. So to do that, what we're going to do is we are simply going to go up to the try_attack function, and we are also going to return if the player distance is above the attack range. So here we'll go if the player distance is greater than the attack range, then also return, okay? And now you should see that attack is only being called when the enemy is within range of the player here. If I go out here, you can see that it stops. So it stays on 11, then when the enemy gets within range, it keeps counting up. Okay, so that is how we can set up the enemy's movement there. Something else we might also want to do is make it so the enemy flips to face its moving direction, because if the enemy is moving to the left, that looks okay, but if they move to the right, that looks a bit strange. So what we're going to do is essentially flip the enemy's sprite based on the player's direction. I'm just going to go down below after we set up our player's distance and direction, and here we are going to go sprite.setHflip. The URL is going to be the sprite component, so hashtag sprite, and flip is going to be true or false for whether or not we want to flip the sprite. So here I'm just going to go player direction.x. If that is greater than 0, then it will flip. Now, if we press play, you should see that the enemy sprite is looking in the correct direction now based on where the player is. If your sprite was by default facing the opposite side, then you can of course just change its greater than to a less than, okay? And just keep experimenting with that until it works correctly. In this lesson, we are going to be setting it up so that the player can finally attack the enemy. We're going to make it so that our projectiles are going to deal damage to them, and they are going to have a health variable, which when it reaches 0, they will be destroyed. So let's start by going over to our enemy script, because we need to create a health variable for the enemy. So at the top here, I am going to create 2 new variables. One called cur HP for our current HP. I'm going to make this 5, and one for our max HP, which is also equal to 5. Now, the reason why we don't just have one variable for health is because we then eventually want to create a health bar, which we need to know the maximum health to show how far down their health has gone. Now, what we're going to do is we are going to create the take damage function. So down here, make sure it's above the on message function because we need to declare it first. This is going to be called local take damage, which is going to have the parameter of self and amount, basically the amount of damage that is going to be dealt. Oops, local function. Okay. So yeah, inside of this function, what we are going to do is we are essentially going to subtract the amount from our current HP. So here I'll go self.current HP equals the current HP minus amount. Then what we can do is check to see if our current health is less than or equals to 0. If so, then delete the object. So if self.current HP is less than or equals to 0, then we can go.delete to delete the object, and there we go. Now, how are we actually going to call this function? Well, when our projectile hits or enters the collider of the enemy, the projectile is going to send a message over to the enemy script. Now, this message is going to be called take damage, and it is going to send over a damage parameter. So down inside of onMessage, here I'm going to go if message ID equals, and the message ID is going to be take damage. Then what we're going to do is we are going to call the take damage function, sending over self and message dot damage, okay? And there we go. Now let's work on actually sending over this message. So to do that, let's go over to our projectile script and go down to the onMessage function. Now, what we are working with when it comes to our projectile, if we select the collision object component, is a trigger. Now, a trigger is different from a collider. A collider is a physical thing that can bump into other colliders, whereas a trigger is sort of like an overlap or a area that can just detect when something has passed through it. We're doing this because we don't really want any collisions happening. We want rather a trigger that can basically just know when the projectile has overlapped the enemy. So inside of our projectile script, we are going to be checking for the message trigger response, which is a message that gets sent by the collision object component when we have hit something else. So here we'll go if message ID equals hash, and here we'll go trigger response. Then what we're going to do, and I'm just going to add some lines so we're not so far down the page. Then what we're going to do is check to see, first of all, what type of trigger response this is, because we get a trigger response for when the collider has entered another collider and for when it has exited. So here I'm going to go if message.enter, which means that this is the frame that the projectile has entered the collider of another object. Then what we're going to do is we are going to basically check then to see if what we have hit is an enemy. Okay, we need to know if what we hit is an enemy. Now to do this, we are going to go to our enemy object. We are going to select its collision object here and go down to where we have group. Now group is essentially a way of grouping these physics objects, okay? So when collisions occur, we know exactly what we are hitting. Now, right now it is set to default and everything is default. So at the moment, we wouldn't know if we hit an enemy, a player, or another projectile. So I'm going to delete default from the group name and enter in enemy, okay? Now this enemy game object is a part of the enemy group. So in our enemy script, in our projectile script, I mean, we can then check to see if the message.otherGroup equals hash enemy. Okay, so if then the projectile has hit an object that is in the enemy group, we know that we have hit an enemy, and thus we can send over the respective message. So here I'll go msg.post. The receiver is going to be the message.otherID, which is the enemy's ID. The message ID will be take damage. And then we of course want to send over our parameter. So that is of course going to be damage equals, and we're just going to say 1, okay? We'll have just everything deal 1 damage at the moment to make it pretty simple. And there we go. And finally, we also want to delete the projectile once it has hit the enemy. So afterwards, we'll just go.delete. Now, if I run this, we should see that everything works. So if I shoot the enemy, you'll see that, well, nothing's happening. Why is that? The reason why nothing is happening is because what we did is we changed the enemy's group. Okay, we changed the enemy's group to enemy, and that caused an issue, and I'll show you why. If we go over to our projectiles game object and select its collision object, we have to go down and change its mask, okay? Group and mask are two things that interact with one another. The group is essentially the group that this object is in, and the mask is what groups that it can interact with, okay? So right now we are saying that this projectile can only interact with objects in the default group. but the enemy is in the enemy group. So we need to set this to be enemy. Now, if you want the projectile to interact with multiple groups, you can simply add a comma and then enter in your second group name, okay? But we are just working with one, so we're going to set its mask to be enemy. Now, if we run this, we should see that it works nicely, okay? The enemy is going to take the hit, and after 5 hits, it will be destroyed. Okay, so that is all working very nicely. Now, we need the ability for the enemy to damage the player. So that is what we are going to be working on in the next lesson. Alright, so in this lesson, we are now going to move on to setting up the ability for the enemy to damage the player. Now, as a bit of a challenge, I want you, inside of our player script, to first of all create the player's health variables, giving them health of, let's just say, around 50. Then I want you to create the take damage function on the player, very similar to how we done it with the enemy, but instead of deleting the player's game object, just print out to the output, for example, say something such as game over. Okay, later on it's going to load back to the menu, but for now it'll just be game over. So have a go at setting up those two things, and I'll be right back to see how you're done. Alright, so let's get started. So the first thing we are going to do is inside of our init function in our player script, we are going to create our health variables. So here we'll go self current HP equals, and I know I said 50 before, but we'll make it a bit harder. Okay, let's make it 10. And then we'll do max HP as well, equal to 10. Next, what we're going to do is we're going to go down and create the take damage function. So just above our on message function, I'm going to create a local function called take damage. It's going to have the self parameter as well as amount. Again, this is going to be very similar to the enemy's take damage function. We're simply going to subtract amount from our current HP. So equals self current HP minus amount. Then we're going to check to see if our current HP is less than or equals to 0. Then we will just print to the console something such as game over, like so, okay? And there we go. Now, what we also then want to do is make it so that the enemy has the ability to tell the player that they are taking damage. And to do this, we're going to go down to the onMessage function and create a new message here, which is if message ID equals, and the message is going to be called take damage. Then what we're going to do is call the take damage function, sending over self, and for the amount, this is going to be the damage property sent over through the message. Now let's go ahead over to the enemy script so we can actually then call this. So if we go to enemy script here, let's go up to where we have try attack. And inside try attack, we're going to replace this print line of code with going msg.post. The receiver is going to be our target. The message ID is going to be take damage. And we're going to send over some properties as well. So the opening and closing squiggly brackets, damage, equals 1, okay, like so. And there we go. So now if we go ahead and play this, let's open up the output here. You'll see that once the enemy is on the player for a bit, remember I think we set them about 10 health, there we go, game over. And that is because the player's health has finally dipped down below 0. So we have the ability to have these damages, but it's a bit annoying because we don't actually know how much health the player has, how much health the enemy has without looking at the console, okay? So to fix this, we are going to be working on setting up some health bars, okay? Which will hopefully clear things up. So let's get started on our health bars. Now to begin, we need to create a health bar GUI object, a GUI. And to do this, I'm going to go to my assets folder, and I'm actually going to create a new folder underneath game. I should have done this earlier on, but I forgot. We're going to call this one GUI. And inside this GUI folder, I'm going to right click, go new, and then go down to GUI. And I'm going to call this one our health bar, okay? So this is the default GUI editor. Essentially, we create a bunch of nodes like boxes, images, buttons, stuff like that. We can then define textures, fonts, etc., and also attach a script which manages the UI. So what we're going to do for our health bar is have two elements, a background and a fill. The background is just going to be a gray box, and the fill is going to be a red bar that goes up and down. So To begin, I am going to right click on the nodes folder right here, go to add, and then select box. Okay, I am going to rename this box to be health bar. Okay, health bar like so, and then we can resize it. So I'm going to go down to where we have size, and I'm going to set this to be 60 by 10, okay, 60 pixels on the width and 10 pixels in height. I think this is going to be a nice little size for our health bar. Okay, but we don't probably want our health bar to be this white color, so if we go down to where we have color, I'm going to click on this little color icon and select a darkish gray. Let's get a bit darker than that. Maybe something like this, I reckon. Yep, there we go, something like that. And now we need a fill, and the fill is going to be the dynamic element that's going to change size. So let's right click on health bar to make a child object, another box, and I'm going to call this one our fill. Now, we of course then need to resize this as well. So we could go ahead and make this 60 by 10, but I want a bit of a border around the outside. So I'm going to set the size to be 56 by 6. Okay, we're going to have a 2 pixel border on each side here. Now, what we need to do is change the color. So I'm going to change the color here to be a red, something such as this, or we can even go down to custom color and choose our own custom red. Something like this perhaps, and click use, and there we go. Okay, so how are we actually going to do the sizing? Well, essentially this is going to be done by, in the script, modifying our fill's X size variable here. Now, if I go ahead and reduce that, you'll see that the health bar is not sizing correctly, okay? It's shrinking from the center, whereas we want it to sort of be like a progress bar where it fills in from the left-hand side. Now, to fix this, what we can do is change the pivot point, because right now the pivot point is in the center. So if we go down and go to where we have pivot, change that from center to west. Now, you can see the bar is going to be like this. We can then move it over so it is nice and centered. And now if I go ahead and change the X size, you'll see that it changes nicely. Okay, that is exactly how we want it to work. Now, how do we actually get it moving dynamically based on the player or enemy's health? And how do we actually get it to follow the player's head? Because if we were to drag this into our scene, it is going to stick to our camera, okay? We need a way of having this match the position of our enemies and our player in world space. Well, that is where the GUI script comes into play. So in my GUI folder here, I'm going to create a new GUI script. Okay, make sure it's a GUI script and not anything else, because this script is designed to work with these GUI elements. And I'm going to call this one health bar. Now, if we go back to our health bar GUI asset here, and we select the main GUI here in the outline, you'll see that there is a script property. Well, we can basically open this up, select our health bar script. Now that health bar script is going to run code for this health bar. Let's go over into the script. We're going to keep the init function. We're going to delete final. We're going to keep update because we need to track the position of the health bar over time. And we're going to keep on message because we need to receive messages from the player to set the health and the position. Now, inside of the init function, we need to keep track of a few things. First of all, we need to know the actual health bar node itself. So this is going to be our health bar node here, which we are then going to be able to move and position around. So this is going to be self.bar node equals, and to get a reference to that bar node, we can go GUI.get node, and the ID for that is going to be health bar. We then need to have access to the fill, because the fill, of course, we need to change the size to adjust the health. And for this, we're going to go self.fill node equals GUI get node, and the ID is going to be fill. And then we need a variable to keep track of the bar world position, so bar world pos. This is going to be sent over by the player to where they want the bar to be positioned in world coordinates. This is just going to equal vmath vector 3. And then, and then we also want one more vector, which is going to be the camera position. So self camera pos equals vmath dot vector 3. Now what we can do is go down to the on message function, and here we are going to be receiving two different messages. The first one is going to be set health, which is going to be sent over by the player each time the enemy or the player takes damage, and that is going to essentially set the health bar. So here we can go if message ID equals hash set health. Then what we need to do is, of course, set the health bar value. So for this, what we're going to do is we first of all need access to the health percentage, okay? Basically a number from 0 to 1 defining how much health the enemy or player has. 0 means they have no health, 1 means they have 100% health, 0.5 means they have 50% health. So here I'll create a local variable called health percent, and this is going to be equal to our message current HP divided by the message max HP, and these two values will be sent over with the message as well. Then we need to actually set the fill node's size, okay, the X size. So for this, we're going to go GUI.set size. The node is going to be the fill node, and the size is going to be vmath.vector3. We only want to modify the X, so if we go over to the health bar, you'll see that at 100% health, it's going to be 56 pixels wide. At 0% health, it's going to be 0 pixels wide. So what we need to do is essentially multiply 56 by the health percent. Okay, and that's going to give us a number between 0 and 56. Then for the Y, we're going to keep that at 6 pixels for the height and 0 for the X. Okay, and there we go. So that's all going to work now. But we don't really have a way of seeing this because our health bar doesn't really work on the screen. If we add to the scene, it would kind of just exist in a little corner, but we want it to track to the player or the enemy's head. So we're going to continue on with that in the next lesson. So this message is going to be called set position, and it is going to send over both the bar world position and the camera position, okay? So here we'll go if message ID equals hash set position. Then what we're going to do is we are simply just going to set these two variables. So here we will go self.barWorldPos equals message.barWorldPos, and we then have self.CameraPos equals message.CameraPos. Now, these message properties we are of course going to be setting as well, so keep that in mind. We are kind of just assuming that these are going to be the values, which of course they will be. Now what we need to do is make it so that the bar can actually track to this position. Now this is going to be similar to how we have done calculating our mouse from screen to world space, but in this case we want to do the opposite. We are converting from world to screen space. So up in the update function, we first of all need to get our screen width and screen height. Now, we've done that before, so we can do it like so. And then we also want to get our screen center, which we have also done before with this line right here. Now, before we continue, we also want to make sure that the camera position, its Z value is 0. So here I'm going to go self.camerapos.z equals 0, just because there may be some depth issues that could occur. And then we are going to calculate the position of the bar from where it needs to go in world space to where it needs to go in screen space. So here I'm going to create a local variable called bar screen pos equals, and this is going to be a little calculation that looks like this. So in brackets, we're going to go self.bar world pos minus self.camera position times 2 for our camera zoom plus the screen center, okay? And this calculation right here basically converts the bar's world position into a screen position, okay? So it can actually be positioned on screen correctly. Then finally, we're going to call GUI.setPosition. The node is going to be our bar, our self.bar node, and the position is going to be that bar screen position. So that is all set up, but we can't really see it in action just yet, okay? We're kind of just writing code, but not really seeing any results. So now let's make it so that our player can have a health bar above their head. So I'm going to start by going over into our player collection, And in our player collection, we want to attach this health bar as a component of player. So I'm going to right click on the player game object, add component file, attach the health bar GUI here. And as you can see, it's kind of just sitting there, not really doing anything. So we need to modify its position in script. So let's go over to the player's script. And then over inside of the update function here, what we're going to do is I'm just going to add a new little area here called set health bar position. And for this, we are simply going to send the health bar a message. So msg.post, the receiver is going to be our hashtag health bar component, and the message ID is going to be set position. Okay. We then have our parameters. So I'm going to have an opening and closing squiggly bracket, and these are going to be our bar world position, which equals our current player's position plus a little bit of an offset vertically above their head. So vmath.vector3, dot vector3 0, and we'll go 30 pixels up and 0. So essentially we're making it so that we want the health bar to be positioned at the player's origin plus 30 pixels, so it's above their head. Then for our second parameter, we have our camera pos, which is equal to our go.getPosition and camera. Okay, and there we go. Now if I press play, you'll see that our player here has a health bar 30 pixels above their center, which is very cool. So the player's health bar is working nicely. Now what we need to do is make it so that when the enemy attacks them, it changes its value. So to do that, we're going to go down to the player's take damage function. And inside of here, we essentially want to send that set health message. So after we adjust our current HP, we're going to go msg.post. The receiver is going to be the health bar component. The message ID is going to be set health. And our parameters here, remember, we have a current and a max HP we need to send over. So current HP equals self current HP. And then we have our max HP, which is our max HP, of course. And there we go. Now, if I go ahead and run this, you'll see that when our enemy attacks us, we are actually getting an error, which is cannot set size on auto size nodes, okay? Now, the reason why this is occurring is because our health bar, if we go over to the health bar here, we actually forgot to change one property, which if we select our fill and go down to size mode, we want to change this from auto to manual. Basically, auto means that the size is being automatically decided for us, and it cannot be changed in script, whereas manual means we have control over it. So let's press play again, and now you'll see that the enemy is chipping away at the player's health bar, which is pretty cool. Okay, now as a bit of a challenge between now and the next lesson, from everything we have done so far with setting up our health bar, with setting its position, and updating its fill for the player, I want you to have a go at setting this up for the enemy, okay? I'll give you a big hint, it's pretty much the exact same process as it was for the player. Hope you had a go at the challenge. Pretty much, we are going to do a very similar process to what we have done already with our player. So let's go to our enemy game object. Right click on the game object, go add component file, health bar GUI, there we go. Now inside of the enemy script, what we're going to do is go down to where we have the update function, and here we are essentially going to set the health bar position by doing pretty much the exact same thing as you can see right here. The only difference is down here for the camera position. We need to access that from the player game object. So here we're going to go player/camera #camera, which is going to be the URL to the player's camera. And there we go. So now if we go ahead and press play, you should see that the enemy has a health bar on top of their head as well. Now the next step is going to be making it so that it goes down when they get damaged. So if we go down to the take damage function here, we can simply set that up like so. Okay, pretty much doing the exact same thing as we done in the player with the set health message. Okay, sending over the current HP and the max HP. So if I play once again, you'll see that when I hit the enemy, their health is going to go down with each hit, which is pretty cool. And that is how we can set up the health bar for our enemy. Now, we have health bar set up. The next step, I think, is going to be making it so that we can start spawning in these enemies over time. Because right now, we just have one. We want to have dozens on screen at the same time, all coming towards the player. So we are going to be working on that in the next lesson. So let's get started with spawning in our enemies. Now, the first thing we need to do is go ahead in our main game collection and create a new game object. This game object is going to be called manager, as this is going to manage the overall function of our game. And as a child of this, we want to create two components. First of all, we'll create the factory component, which is required in order to spawn in our enemies. I'm going to rename this one to be enemy factory, like so, and set the prototype to be our enemy game object, very similar to how we done it with shooting our projectiles. Next, what we need is a script to actually then spawn these in over time. Just inside the game folder, I'm going to create a brand new script, and this one is going to be called Game Manager. The game manager we can then attach as a component to the manager game object by right-clicking, add component file, game manager right here, and there we go. Now let's hop over to our script. We're going to keep the init function, and we are then going to keep update and then delete all others, okay, because we will not be needing those. Now, let's start with our variables. So essentially what we are doing here is we are pretty much every 1 second or so going to pick a random position on our level and spawn an enemy on that position. So what we're going to do is we're going to have a variable here called spawn rate, which is going to be the rate at which an enemy spawns. We'll just keep it at 1 by default, meaning every 1 second. Then inside the init function, we're going to create some self variables, meaning variables that will be changing dependent on this instance. So we'll go self, we'll create a timer, which will be equal to 0, and we'll create a last spawn time, which will also be equal to 0. The timer is going to increase by 1 each second, and the last spawn time is just going to, of course, denote the last time we spawned an enemy, so we can know when the spawn rate has elapsed. Down here in update, we can increase our timer. So we'll go timer equals timer plus DT. And then what we need to do is we need to create a function. So just above update, I'm going to create a function called spawn enemy. And the spawn enemy function is going to do pretty much exactly what it says on the tin. It is going to spawn in an enemy at a random position. So first of all, what we need to do is set the last spawn time to be our current timer time. So here we'll go last spawn time equals self.timer. Then what we need to do is spawn in the enemy. So I'm going to store this as a local variable called enemy. And this is going to equal factory.create. We need to give the factory URL, which is the enemy factory. So hashtag enemy factory. And then we need to define a spawn position. So I'm going to create a local spawn pos variable here, which will equal vmath vector3. And now we need to basically pick a random number for the x and the y. So to do this, we can go, for example, spawn pos.x equals, and then we can go math.random, and then we can give it a minimum and a maximum. So for example, if I go between 0 and 10, it is going to return to me a random number between 0 and 10. But we want to spawn it within our level. So if we have a look at our level here, I'm just going to select my enemy as a reference. What is the furthest left of the x-axis we want to spawn? Let's just say around here. Okay, that's going to be around minus 450, and since we are a square, the positive x is going to be 450, minus 450 on the y, and positive 450 on the y here as well. So what we can do is pick a random number between minus 450 and positive 450. We can then do the same for the y-axis, so spawnpos.y equals math.random between negative 450 and positive 450. And then finally, we can set the enemy's position. So go.setPosition. The position will be spawn pos, and the object we want to set is going to be the enemy. So there we go. Now finally, down inside of update, this is where we want to basically check to see if enough time has elapsed, and if so, spawn an enemy. So here we are simply going to go if the timer minus the last spawn time. If that is greater than the spawn rate, then we want to spawn an enemy. Okay, just like that. And that should be everything set up and ready to go. Now, if I go ahead and run this, we should see that we have our enemy from before, but also we have a new one spawning in, okay? And each second we are having an enemy spawning in and chasing the player around. You'll see they'll spawn in at a random position anywhere on the map here. And yep, that is how we can set up enemy spawning. Now, something you might also want to do is perhaps increase the spawn rate over time so the enemies spawn in faster and faster. So to do that, what we can do is we can simply change spawn rate from a global variable here to one in the init function. So I'm going to delete this and I'm going to create a self.spawn rate. We'll make that equal, let's just say 2 by default. And then we want to replace this down here with that new variable. And over in update, what we can then do is, for example, go self.spawn rate equals self.spawn rate minus, and then we could subtract, for example, delta time times by 0.1. So essentially what we're doing here is subtracting 0.1 from the spawn rate every second, which will give us, I believe, around 20 seconds until the spawn rate is 0. So we probably want to make this a very, very small number, maybe something such as 0.01. So that'll give us a lot more time. Now what's going to happen is that spawn rate is going to get smaller and smaller over time, meaning that the amount of enemies is going to increase over time, okay? And you can, of course, adjust that however you see fit. In this lesson, we are going to begin setting up our menu. Now, our menu is going to be a brand new collection, which is going to have a play and a quit button. Now, this is going to be the first step in setting up our level management system, basically making it so that we can reload the level or transition between other levels, essentially different collections. So to begin, let's go over to our game folder right here, and I'm going to create a new folder called menu. Now, inside this menu folder, we want to create a brand new GUI. So I'll create a GUI, where is it? Right here. And I'm going to call it menu. Okay. Now, inside of the menu here, what we're going to do is we're going to create 3 elements. We're going to have a header, which basically shows the name of the game, and then a play and a quit button. Now, before we add in text, we need to define a font. And a font is basically going to be how big and what sort of typeface this text is going to display. So in the outline, I'm going to go down to where we have our fonts folder. I'm going to right click on that, go add fonts, and I'm just going to choose the default font right here. If you have your own custom fonts that you have imported, you can select those, but I'm just going to select the default one here, and there we go. Now next, we need to create our title or header text. So I'm going to right click on the nodes folder, which defines all the nodes that we are creating for our UI, go add text, and here it is. Now with our text, we want to go ahead and set the font to be that default font, and the text, I'm simply going to call it something such as actionrpg, okay, so it gets displayed like so. Now we want this being in the middle of the screen, so what we're going to do is down here, just going to make this a bit bigger, down at the bottom where we have the Y anchor, I'm going to set this to be top, meaning that if our screen resizes, this UI element is always going to stick to the top of the screen. Now, we probably also want it centered. So what I'm going to do is basically just find the width of our screen here, which is around 960, and divide that by 2. So the X position is going to be 960 divided by 2, and that's going to center it here. Okay, so that's our title. Now we can work on our buttons. Actually, first, let's go ahead and rename this to just be the header so we know what it is. Now let's work on our buttons. So I'm going to right click on nodes, go add, box. I'm going to call this one our play button. We can then bring it to the center of the screen right here. Again, if we want to position it correctly, set the X to be 960 divided by 2. There we go. We can move it down a little bit. We probably want a different background color for this button, so I'm going to go and change the color here to be something maybe such as a purple like that. And our button also needs text. So to add text, we can simply right click on the play button node, go add text, set that font to be the default, and set the text to say something such as play. Okay, and there we go. Now for our other button, we can simply duplicate the play button by going Control-C, Control-V, rename that to be quit button. We can then drag it down, and we can change its text to display quit. And there we go. That is all set up now. You can, of course, choose to make your menu look a bit nicer, but I'm just going ahead and add it in the bare bones so that we can actually get the functionality working with our game. Now, next up, we need to create a script for this GUI, which is going to be able to detect mouse clicks on these two buttons. So I'm going to create a brand new GUI script right here, and I'm also going to call it menu. Back on our menu GUI, let's select its root object here and define the script. So we'll set that to be the menu GUI. Then we can open up the menu GUI script, and inside of here we want to delete everything except for init and for on input. So we can delete all of these. On input we're going to keep because this is how we're going to detect the mouse clicks. Okay. Now what we need to do is inside of init, in order for the on input function to work, we need to give this GUI input focus. So we're going to go msg dot post. The receiver is going to be the game object that we attach this GUI to, so we'll just go full stop. And then the message ID is going to be acquire input focus. So now the input function is going to work. Inside the onInput function, we are looking for the input touch, which is essentially a click. So here we're going to go if action ID equals hash, and here we'll just go touch, and action.pressed, meaning that this is the event where we pressed down on the key, not when we released it. Then what we're going to do is we are going to check to see if it was the play button or if it was the quit button. So to do this, what we're going to do is simply go if GUI.pickNode. Now, what pickNode does is it returns true or false for whether or not the requested node was in the given position. So we give it, for example, the play button, and then we give the X and Y position of our mouse cursor. And if our mouse cursor was inside that node, then it returns true. So for the node, we are going to set this to be GUI.getNode, and the ID is going to be play button. Now for the X and Y, we want to get our mouse's X and Y position. So for this, we can simply go action.x and then action.y. Okay, and that is going to get our X and Y mouse position and return true or false for whether or not our mouse was inside this play button. If so, we are simply just going to print out play, okay, because we're going to get the scene transitions working soon. And then we're going to go else if, and we basically want to do the exact same thing here. So copy this big line of code, and this is going to check to see for the quit button, okay? Now, for the quit button, we don't want to load in a scene, rather we just want to quit the game. We want to close the game down. So what we're going to do is go msg.post. The receiver is going to be the system, so we're going to go at system, and the message ID is going to be exit. Now with exit here, we also need to provide an exit code, which basically tells the engine, you know, was this an exit that we done ourselves? Was it an emergency exit? Was it, you know, what sort of thing? So for debugging, we then know. This was a safe exit, so we are going to give it the exit code of 0. So in here, we can just go code equals 0. And there we go. So that is how we can set up our buttons. So now what we need to do is go ahead and create a menu collection, which is going to be basically the level we'll load up initially. So a new collection called menu. We can then go ahead and create a game object called menu. And then as a component, we can attach the UI. So add component file, where is it? Menu GUI, and there we go. Now to test this out, we need to actually go over to our game project file here, go to Bootstrap and change the main collection just temporarily so that we can test it out. So we'll go main collection as the one to load up. Let's open up the console and let's run this game. So when I press play, it'll launch into the menu. If I click on the play button, you'll see that play gets logged to the console, which is great. So that's working. And if I click off, nothing happens. And then if I click quit, it is going to result in an error. Oh yeah, and this error is occurring because I entered in the system receiver wrong. We have to go at system : okay, and then that should work. So now if I press play and I click on the quit button, that is going to close down the game. Okay, so make sure that the receiver is typed out correctly here. Okay, so for now, what we can do is change our Bootstrap's main collection back to the game for now. In the next lesson, we're going to work on our level management, meaning that we are going to have a game controller collection, which is actually going to be the one we launch into. And that is then, once it's initialized, going to load up the menu. And through the game controller, we can then load in the game as well. So this is sort of going to be the core of our game in loading up all the different levels and managing the overall application. Alright, so let's get started on our game controller. Now, the game controller is going to be the collection we actually load into. And from the game controller, it will then load up the menu and load up our game when we want to transition between the two. So the game controller is kind of going to exist in the background at all times, sort of acting as the core of our game here. So what I'm going to do is I am going to create a new folder inside of game and call this one controller. Now inside of the controller folder, I am going to create a brand new collection called game controller and also a script called game controller as well. So game controller right here. Now inside of the game controller collection, what we're going to do is I'm going to create a brand new game object. I'm just going to call this one GC for game controller to keep it short for when we're writing out the URLs. And then we want to attach the script, so add component file, and then we'll go down to where we have game controller. Now, for this to work in basically loading and unloading our levels, we are going to create what is known as a proxy. Now, if I right click on GC, add component, you'll see here we have a collection proxy. And this essentially allows us to load and unload a level or a collection, which we are using to represent our levels. So if I go down to properties and go to the collection field here, I can, for example, select menu. And then I'm going to rename this one to be menu. We can then create another proxy, another collection proxy, call this one game, and set its collection to be the game collection. Now, inside the game controller script, we can access these components and simply load them in or unload them when needed. Okay, and that is how we're going to create our level transition system. So what we're going to do now is go over to our game controller script and we are going to establish this. So first of all, we need to delete everything except for the init and on message functions. So we can delete these right here, just like that. Delete these comments as well. And now what we're going to do is also create some other functions that we are going to use, okay? The first one, and we'll do these right at the top, is going to be a local function called load level. This is going to take in itself and a level to load parameter. Essentially, this function is going to load in whatever level name we send over. So for example, if it sends over menu, it's going to load up the menu collection. If it is game, it's going to load up the game collection. Now, inside of the init function, we are first of all going to create a variable called current level. So self.current level. And we're going to set this to be nil by default. Nil essentially means nothing. We then want to go ahead and acquire input focus in order for this to work. And then what we're going to do is we are going to load in the menu scene. So here we'll go load, level, self, and then send over the menu. Okay, so this is what we're going to load in at the start of the game. Now let's go and fill in the load level function. So first of all, what we want to do is check to see if we already have a current level. If we do have a current level, then we of course want to unload that because we don't want the menu and the game loaded in at the same time. For example, if we are on the menu and then we click play, we're going to call the load level function for the game collection. And we want to unload the menu first, okay? We don't want to have both the menu and the game existing at the same time. So here we're going to go if self current level doesn't equal nil, so a tilde and then equals nil. Then what we're going to do is we are going to simply post to this current level the unload message. So here we'll go msg.post, sending it to the current level collection, and the message ID is going to be unload. So we're basically telling, for example, the menu to unload, and then we'll go end. Now what we need to do is we need to convert this level to load, which has just been sent over as a menu. We need to convert this into a URL in order for it to function properly, okay? So here I'm going to create a local level URL, and this is going to be pointing to the actual proxy here in the game collection, so pointing to the actual node here. Then what we're going to do is make this equal to msg.url, and we need to go nil level to load. So this is going to construct a URL which is going to point to the respective proxy component. Then what we can do is set this as our current level, so self.current level equals level URL, and then finally we want to load this level in. So we can go msg.post, the receiver is going to be our current level, and the message ID is going to be load. And there we go, that is the load level function. Now, how are we actually going to call this load level function? Well, the way this is going to work is we are going to be sending the game controller a load level message. So here in the on message function, what we're going to do is we are simply going to check to see if the message ID is equal to, then we'll go load level. Now, load level is going to send over a level property. So what we can then do is go load level self and then message dot level, okay? Just like that. And then we also want to know when our collection proxy has finished loading in, because even though it's loaded in, it hasn't really been enabled or initialized, so we have to manually do that as well. So we are then going to be listening for another message, which is going to be called, proxy loaded, okay? And this is going to be called whenever we want to load in a new collection proxy. And what we're going to do here is essentially just initialize it and enable it. So we'll go msg.post, the receiver is going to be the sender, and the message ID is going to be init for initialize. And then what we want to do is also send over the enable message to enable the collection to be visible and playable. And there we go. Now, in the next lesson, we are going to be connecting our menu to this game controller system, as well as our game scene for when the player is defeated, it will load back into the menu. Alright, so now what we're going to do is make it so that when we start the game, we load into our game controller collection. So let's open up our game project, go to Bootstrap, and change the main collection from game to game controller. Now, if I go ahead and run this, you should see that we actually launch into the menu, because remember, over here inside of the game controller, in the init function, we are calling load level for the menu. Now, let's make it so that when we click on the menu's play button, we actually launch into our game scene. So to do that, we are going to first of all go over to our menu GUI script and delete this print line of code here. Now, what we want to do is send a message to our game controller, and the message we want to send is going to be this load level one, sending over the level as a parameter here. So what we're going to do is we are going to go msg.post. Now the receiver is going to be our game controller. Now for this, what we're going to do is we're going to go game controller. So we're going to specify the collection. Then we're going to go :/GC for the game object. Then hashtag game controller for the game controller script. All right. So a pretty long URL right there. The message ID is going to be load level. And then we want to have our level parameter. So in between these two brackets here, what we're going to do is simply go level equals hash, and then we're going to be sending over game, okay, our game collection. Now, if I run this, you see we're in the menu. If I click play, that is going to launch our play scene right here, which is great. Now, let's make it so that when the player is defeated, so when their health reaches 0, it will load them back into the menu scene, okay? And as a bit of a challenge, I want you to go ahead and try that out. So I hope you had a go at that challenge. Pretty much what we're going to do is go over to our player script and then scroll down to where we have the take damage function, okay? And here right now we are simply printing game over when the health is less than or equal to 0. But what we want to do is call that load level message on the game controller again. So we'll go msg.post. The receiver is going to be the game controller collection, :/gc. Hash for the game object, then hashtag game controller for the script. The message ID, this is going to be load level. And then we have our level parameter here, which we are going to define as level equals hash menu. And there we go. Now, if we go ahead and run this, we should see that when we press play and we get defeated by an enemy, we're going to go back to the menu when our health reaches 0, and there we go. We can click play again and basically go through the game loop once more. Okay, so we now have a successful game loop going on, and that is all for that. So in the next lesson, what we're going to do is start working on a bit of the more flashy elements, like adding in damage flash and sound effects. In this lesson, we are going to be setting up damage flash. Essentially, when the enemy or the player gets hit, we are going to flash their color to red or to black or to blue or to whatever you want for a fraction of a second, just to show that they did indeed get damaged. So what we are going to do is start off with our enemy. And the way this is going to work is we are going to access our enemy's sprite component and change what is known as its tint. Its tint is essentially a color that gets multiplied by each pixel. So for example, if the tint was white, white multiplied by red is still white, because if we are talking about numerical RGB values, white is 1. So 1 times something is pretty much the same thing. Whereas if we multiplied it by black, it would turn 100% black. Likewise, if we multiply it by a red color, there will be a red tint given to the entire image. So let's go over into our enemy script and look at how we can actually first of all change its tint. So I'm going to do this in the init function here. And to do this, we are going to go go.set. And with go.set, we can actually change a game object's or a component's property. So here what we're going to do is the URL is going to be hashtag sprite for the enemy sprite. The property is going to be tint, and the value is going to be a color vector, okay? And colors are represented as a vector 4, an RGB and A value, red, green, blue, and alpha, which is transparency. So here I'm just going to go vmath.vector4. For the red, it'll be 1. For the green, it'll be 0. For the blue, it'll be 0, and for the alpha, it'll be 1, okay? So what we're doing here is essentially setting the sprite's color to be red. Now, if I go ahead and run this, you should see that when I press play, our enemies are all going to be this reddish color, okay? And this is what we're going to flash them for a fraction of a second when they take damage. So what we can do is then basically copy and paste this line in from the init function and bring this down to the take damage function here. Okay, so I'll post that in like that. Delete the one that we defined up here in init. And now if I press play, you'll see that if I hit the enemy, they turn red, but they don't turn back to its normal color. So how do we do that? Well, what we need to do is essentially create a variable which is going to define the time at which we want to reset their color. So here I'm going to create a self.resetColorTime equals 0. And then down inside of the take damage function, we are going to set this value. So after we change the enemy's color, we are going to go self.resetColorTime equals our self timer plus and something then like 0.05, okay? So essentially we are saying that we want to reset our color 0.05 seconds in the future. Now what we can do is over inside of the update function, we can check to see if the timer exceeds this reset color time, we can change its color back to be white. So I'm just going to copy and paste where we change the tint, go up to the update function here, and then what I'm going to do is simply go if self.timer is greater than or equals to self.reset color time, then what we're going to do is paste that in. And the color is going to be 1, 1, 1, 1, okay? The RGBA is all going to be set to 1, meaning white, okay? And again, the tint, this does not mean that we are changing every pixel to be white, but rather we are multiplying every pixel's color by white, which will make it its default value. So now, if I go ahead and press play, you'll see that when I attack this enemy, they're going to flash red for just a little fraction of a second, okay? I'm not too sure how it comes across in the video with the frame rate, but you should be able to see it coming along just nicely, and when you play, it does work a treat. Now, as a bit of a challenge, I want you to go ahead and set it up so that we can have this sprite flash for the player as well. A big hint is that it's pretty much going to be the exact same process, but over in the player script. Pretty much, we want to do the exact same thing as we've done here inside of the enemy script. So over in the player script, we'll go up to the init function, and we will create its reset color time variable right here. So reset color time equals 0. Then over down in the take damage function, we can basically change the player's sprite color to red, and also then set the reset color time like this. So we are basically accessing the sprite component and setting its tint variable to be red. Then we are adding or setting our reset color time to be 0.05 seconds in the future. Likewise, we then want to go up to the the update function here. And inside the update function, we of course want to check to see if the timer has exceeded the reset color time, and if so, we want to set its sprite tint back to white. Okay, so basically the exact same thing as we've done with the enemy. Now, if we go ahead and press play, we should see that when the player takes damage, they also flash red, which is very nice. So now we have just a little bit more of a visual indicator to when the damage is occurring, along with our health bar. Now, another indicator we are going to implement is going to be audio. We are going to have audio effects for when the player shoots, for when they take damage, and for when they damage enemies. We are going to be setting up audio for our game. So we're going to have a sound effect for when the player shoots, for when they take damage, and for when the enemy takes damage. Now, to begin, let's start with when the player shoots, okay, the shooting sound effect. Now, at the start of this course, we imported some assets, more specifically some audio assets, which included an enemy damaged, player attack, and player damaged sound effect. Now, to implement these, let's go over to our player collection. And inside of here, I'm going to open up the player object, and I am going to create a brand new component to the player called sound. Now, this sound I'm going to rename to be attack, or shoot sound actually, we'll call it shoot sound. And then we can specify a sound clip by clicking on these three little dots, selecting player attack, okay, and there we go. Now, we can also modify things such as the gain and the volume and stuff like that, but we're not going to worry about that too much. Now, let's hop over into our player script. We simply want to go down to the try shoot function, and at the bottom, we are going to just enter one line of code. That is going to be sound.play. We give the URL, which is the hashtag shoot sound component, like so, and that's it. Now, if we press play, we should see that when I shoot, that sound occurs. Okay, pretty cool. Now, let's implement the player when they get damaged. So inside of our player collection, I am going to create another sound, and this one is going to be called damaged sound, or we'll just call it damage sound actually. We can then specify that to be the player damaged, and then inside of the player script, we can go down to the take damage function and set that up. So here we are then going to go sound.play, the URL, hashtag damage sound. Now, if we run this, we should see that whenever the player gets hit, they have that sound playing, which is pretty cool. And then finally, we have a sound for when the enemy gets damaged. So for this, we're going to hop over to our enemy game object, and we are then going to create a sound component. We're going to call this damage sound again, and that sound is going to be enemy damaged here. And just like with the other two, we'll go over to our enemy script, go down to the take damage function, and in here we can then call that. So sound.play, the URL being damage sound. Okay, so we can save that, run, and for the last time we should see the enemy has that sort of damage sound when they get hit. So yeah, that is how we can add sounds to our game, and you can see how pretty easy it is. It's literally just adding one component and then having one line of code to actually play the sound. So feel free to go ahead and add many more sound effects. You might want a sound for when the enemy attacks. You might want the sound for when the enemy is crawling. You might want to add music to the background. Really, you can do a lot when it comes to sound in your games. Congratulations on completing the course. We just finished looking at setting up an action RPG inside of the Defold engine. So our game featured a player who can run around and defeat enemies by shooting out projectiles. We looked at a number of different systems inside of the Defold engine, from a top-down player controller to the camera follow script, which had it clamp its bounds to the map. We even created a simple enemy AI where the enemy would chase after the player, and when they get within range, they would begin their attacks. We also looked at setting up health bars, a level management system, and object spawning for both the projectiles and enemies. Zenva is an online learning academy with over 1 million students. We feature a wide range of courses for those who are starting out or for those who just want to learn something new. The courses are also very versatile, allowing you to learn in really many different ways. You can choose to watch the video lessons, read the included lesson summaries, or follow along with the instructor with the included course files. So thank you very much for following along, and I wish you the best of luck with your future Defold games.